Greetings everybody. In today's video I'm going to talk about Kerberos Referrals or authentication in multi-domain or multi-forest environments. But before moving into the video, let me say that if you haven't watched my previous video about Kerberos, you need to go and study that first, because in that video I talk entirely about the Kerberos and tickets and how everything relate to each other. But in this video I'm going to talk about Kerberos Referrals. I will summarize the whole Kerberos protocol and authentication in this video too, but it's better you have a good understanding of Kerberos before moving to this video. Stay with me and enjoy the video. So, Kerberos Referrals. What are these? In order to fully understand this, we need to take an example. Let's say that inside the domain we do have a client, but that this is not the only domain that we have. That domain is the child domain of more domains, which in case we can say that we are facing with a forest, a hierarchy of domains. As you can see, the name metskills.fr, and there are two more child domains for that, and different child domains. So the client needs to approve access of the user account. So in that case, the user account and the client will go talk to the KDC in order to issue TGT, TGS and things like that in order to fully get authenticated by both, by KDC. So the user will basically talk to the KDC and will generate TGT from and receive a TGT from Kerberos, and then will be able to log into that client. I'm not gonna cover how this phase will happen because I already talked about it in my previous video, Kerberos authentication. But we assume that this client has already been authenticated and the user is already logged in to that client, which means that this part is already done, and I talked about it in my previous video. It means that the user account has a valid TGT from Kerberos, from local DC, and that TGT is inside the RAM. But the point is, this client or user wants to log in to a file server, and that file server is in another domain, and that domain is in another forest, which again we are facing with a different forest, a hierarchy of domains, and different namings for that. So, what do we mean by connecting? We mean connecting to a file server by using UNC, and which will trigger the SPN of CIFS by connecting to a share folder. So, this client wants to log in to that file server. In order to that happen, we must have a forest trust between two forests. Otherwise, it's not gonna work. So we need to have a forest trust between these two different forests in order to fully route the client to file server. So after that, the client will form a packet, and inside the packet it will place the TGT that had already been issued by the local DC. And also it will place the service principal name. As we said, it's going to be CIFS for connecting to the file server of the remote forest, this one, and of course some more information like expiry date and UPN and other stuff. This packet is called Kerberos Ticket Granting Service Request. Actually, we are requesting to access to service. You must have forgotten that beside TGT in RAM, there's also another key. I'm talking about this one. Using this key, which was already issued by KDC again, this is called session key, and this session key will actually encrypt the whole information and communication between the client and the DC, between these two. So this session key will be used in order to encrypt the upper part of the packet. So that part will be encrypted. Once the whole thing is encrypted, the client will need to send this to the local DC. And local DC is this one, the very first DC available in its own domain. So the packet will be sent to the local DC. Once the DC receives this packet, it will try to analyze and see what's inside. It will see that the service principal name is CIFS, and that CIFS is pointing to a file server to another domain. And that DC doesn't know. The local DC does not know where that server is. How do we can find it? Firstly, it will query the local database, its own database, which is called NTDS, to see if it can find anything about that service principal name by that name. Since it doesn't find anything, so it will do the next thing. This service principal name cannot be found because it is located in another forest, and in that case it has to undergo for some sort of other process, and this process is going to be like this. This TGT is already encrypted, and if you remember, we talked about this TGT. It is encrypted with the master key of the KERB-TGT account of the domain, and that one is also encrypted by the session key. But the domain controller does not have the session key itself. He needs to fetch the session key. Where is the session key? It's inside the TGT. The DC will take a look at the NTDS, find KERB-TGT account, and grab the password. Using that password, TGT will be decrypted. Once TGT is decrypted, it will find the session key inside, and the session key will be used to decrypt the upper part. So by that case, KDC can say that the user is who is claiming to be. But again, it doesn't know anything about the service principal name CIFS. So after that, KDC will actually do a second process, which means that since KDC was not able to locate that service principal name inside this domain, it will follow us like this. It will ask someone that knows everything about the forests, knows all the objects in the forest, and that thing is going to be global catalog. Because global catalogs are servers that know everything inside a forest. Remember, everything inside a forest, not other forests. When KDC asks the global catalog, it doesn't find anything about it, because the scope and the searching scope of the global catalog is going to be its own forest, not the remote forest. So once again, it doesn't find the service principal name, but it will find something relating to this communication. It knows that file server is ending with the naming of medsys.ca. And once it takes a look at all the objects inside the forest, it will find something in the root forest. And that something is the object that is pointing to the forest trust. If you know that when you establish a trust, there is going to be always objects associated to those trusts. So it will find the object, it will say that I'm not sure which the service principal name is, but I found something with the same name like that. So I believe it should travel the trust to reach the destination. So because that object is in the root forest, it will find that this forest trust is between two different forests. The first side is medskills.fr and the second side is going to be medsys.ca. Having said that, it will find that the service principal name is ending with medsys.ca. So it says that the authentication process should follow the trust path, which means that it will go like this until it reaches the destination. In that case, the second hop is going to be the parent of paris.idf.medskills.fr. I'm talking about this one, the parent one. In order to reach that, it must contact the domain controller for that domain. So the KDC will need to contact that domain controller. In that case, the domain controller will remove the SPN and generate a session key and encrypt the upper part again and place that session key inside the TGT again. After that, it will generate a referral. This is exactly what referral is going to be used for. So the referral is basically a TGT that the client can present that to a parent domain in order to have access to another thing. So the KDC will generate a referral for service principal name of the parent domain, which is going to be kerbtgt idf.medskills.fr. And also, this referral packet is going to have more information. Information like where it's coming from and where it's going to. In order to simplicity, we're just going to call this kerbtgt, and we understand that this kerbtgt is going to refer to another domain. So this packet will need to be encrypted, but a key is always needed in order to encrypt the entire packet. In that case, KDC of Paris domain and KDC of IDF domain needs to have a key which is shared between them in order to encrypt and decrypt this packet. As we know that there is a trust between these two. Between these two domains, there is always going to be a trust. And this trust is going to be a default trust because child and parent domain is always default trust. So for each trust, we do have objects representing that trust. So we have an object at Paris side, and there's going to be an object in IDF side, which means that they both understand about the trust. So this object will contain a master key, and this master key will be used in order to encrypt the TGT. Once it is done, the packet is ready. This packet is called kerbtgs reply. The packet will send back to the client, and then client will resend it back to the parent domain. And the KDC will find that this packet is being referred by someone else. So it should treat it as a referral thing. So it uses the key to decrypt the TGT. Once it is decrypted, the session key is found. And using that session key, the authenticator can be decrypted. And again, it removes the kerbtgt account, and it will need to contact to a parent domain because the packet and the authentication flow needs to basically follow the trust path. So again, this time is going to again point to the parent domain. This case, the domain name will be medskills.fr. It will place the information inside the service principal name, and the service principal name is going to be kerbtgt of the parent domain. One more time, a session key is generated, and that session key will be placed inside the packet, and of course the authenticator is also encrypted. We do have a trust here too. So when we have a trust, we do have a key. Using that key, the TGT will be encrypted. Once it is done, again the whole packet will send back to the client. And the client, once it receives the packet, it will send this packet to the domain controller of the medskills.fr. So the packet will be sent there, and of course the KDC of the domain medskills.fr will find that this packet is again a referral packet. It will use this key to decrypt the TGT and fetch the session key. And the session key will be fetched and the authenticator will be decrypted. Once it is done, it's not yet finished. So again, it must travel to the next destination. And the next destination is going to be the forest at the right. So in that case, again, the SPNs will be changed with the new SPN, and that Kerb TGT is going to be the service principal name for the forest medsys.ca, the forest at the right. One more time, once we have a trust, we do have the object. A session key is generated, and this session key will be placed inside the TGT, and of course the authenticator will be encrypted. Using the master key of the forest, the TGT will be encrypted. And once it is encrypted, it will be sent back to the client. Once the client receives that, it will send it back to the KDC of the remote forest, the root forest of the remote forest. The KDC will find that and use that master key in order to decrypt the TGT. And of course, when the TGT is decrypted, the session key will be fetched and it can use it to decrypt the authenticator packet. Next step, it will search for this Kerb TGT. It knows that this is coming from a remote forest. In this case, the remote forest is medskills.fr. So basically, it will search the entire forest in order to find if this SPN is actually inside the forest or not. So who knows everything inside the forest? It's going to be a global catalog. The global catalog, as we said, is responsible to find every object inside a forest. So global catalog search for that service principal name and will find that the service principal name actually is residing in that domain, montreal.kbk.medsys.ca. Once it is done, it knows that it must travel through the trust path. So the next hop is going to be kbk.medsys.ca. Having said that, the SPN will be replaced in order to have a referral to the next hop, to the next child. A session key again is going to be created, and once the session key is created, the authenticator is encrypted and a copy of the session key will be placed inside the TGT. And of course, we do have a trust, and once we have a trust, we do have the key. That key will be used in order to encrypt the packet. And again, you know that this packet will send back to the client. Once the client receives that, the client will need to contact that DC. So again, the whole packet is going to get transferred to the local DC of the qbq.medsys.ca. Since that one have a corresponding key, it can easily decrypt the packet. It decrypts the packet, and inside it will find the session key. Using the session key, the authenticator will be decrypted in order to understand and verify if the user is actually the one he is claiming to. So once it is done, it is not yet finished. There is one more destination. SPN will be changed in order to have a referral packet to the montreal.qbq.medsys.ca. And again, a session key will be generated. The session key will encrypt the authenticator and will be placed inside. And since we have a trust, we do have the key. The key corresponding to that trust is used to encrypt the packet. Once it is done, it will send back the ticket to the client. And the client will find it. But the point in here is that if the client takes a look at the SPN, it will find that the SPN is a referral to kerbtgt.montreal.qbk.medsys.ca. And the originating service principal name was called CIFS File Server Montreal.qbq.medsys.ca, which means that the client has reached to the destination. When I say destination, I mean the destination domain controller, not the destination file server. So the client will know that it can send a request directly to have access to that file server because it already has reached the destination domain. So in that case, this service principal name and this service principal name ends with the similar naming. So it means that it has reached the destination. So it will use the original SPN and place that original SPN inside the packet. Once it is done, it is ready to send it back to the KDC of Montreal. The packet will send back to the DC, and DC will take a look at this SPN and will see that this SPN maps to a file server which is inside its domain. So KDC knows that it is authoritative to answer this request. So using that key, the entire packet is decrypted and the session key will retrieved, and that will be used to decrypt the authenticator. At this stage, KDC can say that the user is exactly the one who was claiming to be. But the authentication is not yet finished. It should send this back to the client so that client can access the file server. So how this is going to be done? As we already talked about in my previous video, every security principle in Active Directory do have password. We're talking about the users, we're talking about computers. So computers do have a password too. In order to have mutual authentication and make sure that only file server will be able to read the packet, the KDC has to encrypt the packet. And the only key which can be used in order to encrypt the entire packet is going to be the key of the file server, the password of the file server. These file server and DC also share a password. This password is only known to the KDC, the domain controller, and the file server. Nobody else knows anything about this. So in that case, it follows like this. It generates a session key, and the session key will be used in order to encrypt that part. And it will place the session key inside the TGT. Right after that, it will need to encrypt that part, the blue part. But we need to fetch the key corresponding to the file server. In that case, it will take a look at the database, and it's inside NTDS, it will find the file server. And for that file server, there's going to be a key. Using that key, it will encrypt the entire TGT, and once it is encrypted, it can send it back to the client. Don't forget that this packet is still called Kerberos TGS reply because it was sent here by the KDC of Montreal domain. So this packet will again send back to the file server this time in order to have access to the share. And file server needs to understand who is the one who wants to connect to me. So take a looking at the packet. It knows that there is a key that he can open the entire packet, and that is going to be the password of the file server, of the master key of the file server. It will use that key in order to decrypt the TGT, and inside the TGT, it again will find the session key. Using that session key, again, the authenticator will be decrypted, and at this stage, the file server can say that Sarah is exactly as Sarah, which means that the person who's claiming to be Sarah is Sarah. So, we can say that at this stage authentication is performed. And that was the entire purpose of Kerberos Referrals. But there's one more thing that we need to add. What happens if the client has not access to the file server? What do we mean by that? I mean that when there is a deny permission of the file server, what happens? Well, I have to say that this problem is not the problem of the KDC. Authorization is done by the operating system. So the file server will take a look at this part. If you remember, this part was the group membership of the user. And taking a look at the ACL of the entire folder, it will see even if the Sarah has enough access to access this share or not. If she has, she will have the access. She can simply open and browse the file. Otherwise, it will fail. Authentication is done, but authorization is done by operating system, not by Kerberos. I hope you enjoyed this video. I know this was somehow difficult to understand Kerberos Referrals because there are so many session keys and TGTs and TGS and things like that inside. But I tried to explain it in a most clear way in order to fully understand this concept of Kerberos Referral. Thanks for watching. Enjoy your day.